Okay, so we're going to do another video on inelastic collisions, two-dimensional inelastic collisions. So 2D and this time no right angles, but we have the mathematics to make it not so bad. Okay, so suppose I have, let's just come in like that and make it, say, 3 kilograms coming in at 2 meters per second, and then we have this coming in like this at, let's call that 4 kilograms at 5 meters per second. And I just kind of sketched it out. I'll just sort of make an estimate here, and we're going to say that that is, roughly 115 degrees, 114 degrees. So we're going to say there's a 114 degree angle between those two vectors. Okay, well, that's fine. If I sort of extend this up like this, then we're going to say that this angle in here is 180 minus 114, which is going to be 66 degrees, right? 70, 80 plus 100, so that's going to be 66 degrees. Good. So now what I'm going to do is I'm going to say that this momentum, call this object 1, call this object 2, P1 is going to be 6 kilogram meters per second, and P2 is going to be 20 kilogram meters per second. And I'm just going to sketch roughly. Let's make that 20. Let's draw that one first. Kind of draw it up in the same direction. Something like that. We'll make it 10 centimeters long, approximately. And then we're going to add this one to it. So that one, 6, we'll make it 3, we'll make it roughly, make them roughly parallel. And we'll say that's 3. And label them 20 kilogram meters per second, 6 kilogram meter per second. And let's see, so we got to figure out this angle here. That's also going to be a 66 degree angle. So that's going to be a 66 degree angle. And so now we're going to solve for that. Well, we're going to go c squared is equal to a squared plus b squared plus 2ab cosine, I'm sorry, that's a minus 2ab cosine c. Okay, so c is going to be the square root of 6 squared plus 20 squared minus 2 times 6 times 20 times cosine of 66 degrees. Six squared plus 20 squared minus 2 times 6 times 20 times cosine of 66, and I get C is 18.4 kilogram meters per second. And then let's find this angle down here. So now I'm going to go up into this space, and I'm going to go sine of theta over 6 kilogram meters per second is going to be sine of 66 degrees over 18.4 kilogram meters per second. And so I'm going to get theta equals sine inverse of 6 times sine 66 degrees divided by 18.4. Shift sine 6 times sine 66 divided by my answer from the previous line, and I get 17.3 degrees. We'll call it 17 degrees. And then finally I want to know what that velocity is. So I found what that momentum is, but I want to find out what that velocity is. So I'm going to say that P equals mv, and so 18.4 kilogram meters per second equals total mass, so 3 plus 4 kilograms, V. So I'm going to get V is 18.4 divided by 7, 2.6 meters per second. Okay, so to recap that, we had a 3 kilogram object shooting this way at 2 meters per second, a 4 kilogram object shooting that way at 5 meters per second, and then overall the momentum vectors are going to be that momentum vector plus that momentum vector. We're going to have an overall momentum of 18.4 kilogram meters per second, 17 degrees off of the line, off of that line, and so then these two balls are basically going to go that way. And they're going to go that way at a speed of 2.6 meters per second, and that angle is going to be 17 degrees off of that dotted line. So that angle right in there is going to be 17 degrees. Okay, so there, it's not too much harder. You just have to use law of sines and cosines, but basically you set it up the exact same way. You find the momentum vectors, you put them into a triangle, you solve the triangle, and then remember that at the end you've got a momenta, and so then you have to divide by the mass to figure out what that final velocity is. Alright, we'll be back with 2D elastic collisions in a second.